Welcome to the last section of Unit 2, Radical Equations. The second we say that something has to be solved, that means you're going to be solving for x. That means it has to have an equal sign in it, okay? And you always, always, always have to check radical equations because sometimes your answer is extraneous, okay? If it's extraneous, that means it doesn't work and you would have to reject it, okay? So I'll show you some of those today also. So these are the steps. First step is to isolate the radical so that you make sure that they're on their own side of the equal sign, okay? And then what we'll do is we'll raise each side to whatever index the root has, okay? And then we solve and check. What I mean by root and index is this. Example 1. I always draw a line down my equal sign. That's telling me that I'm going to solve for x, and whatever I do to one side, I have to do to the other. So right now the index is a 2. That means I need to square both sides, okay? Because whatever this index is what I'm going to put up here. So this radical is already isolated by itself. I didn't have to move anything away from it, so I can go immediately to raising each side. The square root and square cancel. I get x minus 1, and this side gives me 4. And this is simple. We add the 1 to both sides, we get 5. Again, we always check. So x minus 1 inside the radical equals 2. I'm going to solve this side. I'm going to plug in a 5. 5 minus 1 is 4, and the square root of 4 is 2. So that equaled this side. It checks. That's my answer. Okay? Next example. Draw a line down. I see this radical is not by itself, so I need to move the 5 to the other side. When I move the 5 to the other side using subtraction, I get negative 3. So now, again, the index is really a 2. I'm going to square this side, and I'm going to square this side, making sure I use those parentheses. The square root and square cancel. I get x minus 1, 2x minus 1. This side, making sure of the parentheses, we know that that is a positive 9. Add the 1 to both sides. Divide both sides, and I get x equals 5, okay? Has to check. 2x minus 1 plus 5 equals 2. 2 times 5 minus 1 plus 5. 2 times 5 is 10, minus 1 is rad 9. Rad 9 is 3. 3 plus 5 is 8. That does not check. There's our example of an extraneous root. This is an extraneous root, which means this gets rejected. And if it's rejected and there's no other solution, then our answer is no solution. A common mistake is that when you reject this, you don't write an answer. Okay, if you reject this, then there's no solution. You need to actually write no solution, okay? Otherwise, you don't have an answer. So this one had x equal to 5 as the answer. This has no solution as the answer, okay? So next example, drawing a line. This is already isolated on its own side, so I'm going to square this side, and I'm going to square this side. That means this binomial is going to multiply by itself. Okay, you don't just distribute a square. That doesn't work. You write the function twice. Okay, so these cancel. I get 5x minus 9. This side I would FOIL or box. X times x. Outer is negative x, inner is negative x, that's negative 2x, and last is plus 1. Now, when I go to solve this problem, it has a squared, so I'm not going to start trying to solve for x. When it has a squared, if you remember from Algebra 1, you move everything over to the squared side. So if I subtract 5x, I'm going to get negative 7x. If I add 9, I'm going to get a positive 10. So now that I have this ax squared plus bx plus c form, I factor it. Factoring was early in September. If you're having difficulty with factoring, watch some more videos, come for extra help, come to Hoops, whatever you need, okay? Now we know that factors always have opposite roots, okay? And that's found, like I showed in class again, x minus 2 equals 0, we move it over. X minus 5, we would move it over, okay? So we have two roots, or two solutions. We need to check both. So I'm going to write the original equation twice. So the first one, I'm going to sub in a 2. And the second one, I'm going to sub in a 5. Okay? So this side gives me 1. This is 10. 10 minus 9 is 1. And the square root of 1 is 1. That checks. This side gives me 4. This is 25. 25 minus 9 is 16 inside a radical. And that gives me 4. Remember, the radical was already here. We didn't place the radical here, so I don't put a plus negative, like when you're solving and you have to square root each side. Okay, so 4 equals 4. Both of these answers are solutions. Okay? Next one, draw a line. I already have it isolated by itself, so I'm going to square this side and I'm going to square this side, making sure I write it in parentheses and knowing that that means write it twice. No shortcuts with that. Okay, the square root square cancel, 30 minus 2x. This, when you multiply, gives you x squared minus 6x plus 9. And again, I have a squared, so I'm going to move all of this to the left side. So negative 6x adding the 2x is going to give me negative 4x. 9 minus the 30 gives me negative 21. Factor that. X minus 7, x plus 3. Factors are opposite the roots, so x minus 7 gets set equal to 0. Add the 7 over, I get 7. X plus 3 sets equal to 0. I minus the 3 over, I get negative 3. Check both. So write the original equation twice. Substitute the 7 in one of them. And the negative 3 in the other. I'm going to use parentheses for that since it's multiplication. This side gives me 4. And this side gives me 30 minus 14. 30 minus 14 is 16. And the square root of 16 is 4. That checks. This side gives me negative 6. This is 30 minus 2 times negative 3, which is 36. The square root of 36 is 6. And 6 does not equal negative 6. So this doesn't check. So this doesn't work. It's extraneous. Okay, that's that extraneous root. So we reject it. This is my only answer. Okay? Next. Isolate the radical. Well, this is isolated on this side and isolate on this side. They're already isolated per side, so just square both. 5x plus 3, because the square root and square cancel. 3x plus 7, because the square root and square cancel. And now there's no squared on either one of these, so I don't try to bring everything to one side. I just start solving for x. Move the 3x over by subtraction. Move the 3 over by subtraction. Divide, I get x equals 2. Yes, you have to check it. Okay, we check everything when there's radicals. You should check everything regardless if there's a radical or not, Because don't you want to know whether you're doing it right before you turn in a paper, especially on the regions? Okay, so this is 10 plus 3 is 13 as a square root, and that's not a perfect square. I'm not going to go further. And this is 6 plus 7, which is also 13 as a perfect square. Here we have the reflexive property. Rad 13 equals rad 13. That checks. There's my answer. Good. Okay. Next one. This one's a little different. I do have the radicals on each side, but they're not isolated. They have these. Well, the only way to get rid of these if they're coefficients really means by multiplication. I don't want to start dividing these out. It'll get really ugly. Okay? So instead, you know you need to square things to get rid of the square root. You can do the same thing with those coefficients. Okay? Now, you just have to be careful because this really means 2 squared, which is 4. And then the square root and square cancel, so x plus 8 comes out. But remember, that 2 was there by multiplication. So the 4 is here by multiplication, and this was a binomial, so lock it in. I'll explain that again on this side. The 3 is attached by multiplication, but it is being squared, so it's 9 times. The square root and square cancel, so it's x minus 2, but that was a binomial by itself. Okay? And now we just solve regular, like you've been doing even in middle school. You did this kind. Distribute 4x, distribute 32, distribute 9x, distribute negative 18, and now start solving. I'm going to move the 4x over. By subtraction, I get 5x. I'm going to move the 18 over by addition, and I get 50. Divide both sides, I get x equals 10. Check it. 2 rad 10 plus 8. 3 rad 10 minus 2. Okay, so this is 2 rad 18, and this is 3 rad 8. Well, they don't look the same. You could type this in the calculator, get the ugly decimal since it's irrational, and do the same thing for this. You'll see they equal each other. But I'll do a quick little review. We know there's a perfect square in there. Rad 9 times rad 2. Rad 9 is 3. So 2 times 3 times rad 2 is 6 rad 2. This has a perfect square of rad 4. Rad 4 is 2. 3 times 2 times rad 2 is 6 rad 2. Now you do see the reflexive property. You know it checks. That's your answer. Okay? So this was old review. All right. So we see these are already isolated. I'm going to square and square. This square root and square cancel. X equals 5. This square root and square cancel. X squared minus 15. And now just start solving. I have the x squared on this side. I'm going to move the x over. I'm going to move that over. And now factor. X minus 5, x plus 4. Opposite, opposite. Okay, and then check. Okay, I'm going to stop at this point because we're almost at 15 minutes. So you would have to check both of these twice. Okay, so in the first one we check 5, and the second one we check negative 5. Okay, I'm going to check you on that and see that you did that in your video tomorrow. Okay, and then we will do this one together. Okay, so we have to make sure we isolate it. This will be our do now for tomorrow. Okay, I'll see you. Bye.